Every city, every bridge, and every modern structure begins with a simple material that most people never notice. Hidden behind walls and beneath roads is a substance that has shaped human progress for thousands of years: cement. Visual description: aerial shots of massive cities, highways, skyscrapers, bridges, and construction sites. The camera slowly moves toward a huge cement factory surrounded by mountains and industrial landscapes. Before becoming the foundation of modern construction, cement begins as natural minerals hidden deep inside the earth. Limestone, clay, and other materials hold the secrets of this extraordinary transformation. Visual description: show limestone mountains, workers collecting raw materials, geological formations, and close-ups of rocks. Humanity's relationship with cement stretches back thousands of years. Ancient civilizations discovered materials that could harden and create structures capable of surviving generations. Visual description: ancient stone structures transition into modern concrete buildings, showing the evolution of construction. Today, cement factories are among the largest industrial facilities on Earth. Behind their enormous walls, a complex process transforms simple minerals into one of humanity's most important materials. Visual description: exterior shots of giant cement plants, conveyor belts, towers, rotating structures, and industrial workers. Although cement appears simple, its creation depends on a precise combination of natural materials. Limestone provides calcium, while clay, iron, and other minerals complete the chemical foundation needed for strength and durability. Visual description: close-up shots of different raw materials, limestone rocks, clay deposits, mineral samples, and workers analyzing materials inside a laboratory. After extraction, thousands of tons of raw materials begin a carefully controlled journey. Giant trucks and conveyor systems transport these materials toward the heart of the cement factory. Visual description: large mining trucks carrying limestone, conveyor belts moving rocks, and factory receiving areas. Cement is not created by simply mixing materials. It is the result of a complex chemical transformation where heat, pressure, and precision combine to create a material capable of supporting the modern world. Visual description: laboratory simulations, chemical analysis, factory control rooms, and engineers monitoring production data. Without cement, modern civilization would look completely different. Homes, hospitals, schools, transportation networks, and cities all depend on this essential material. Visual description: construction workers building homes, bridges, hospitals, and roads using concrete. Every day, cement factories around the world produce enormous quantities of material. This massive industry operates continuously to meet the growing needs of billions of people. Visual description: night shots of cement factories operating, glowing industrial lights, endless production lines. From ancient discoveries to modern megastructures, cement has traveled through time with humanity, but the true transformation happens inside the factory, where raw earth becomes the foundation of the future. Behind these enormous walls lies a process of engineering, heat, and precision that few people ever see. Visual description: camera slowly approaches the entrance of a cement factory. Conveyor systems disappear into darkness, creating mystery before the production process begins. Inside the cement factory, a carefully designed production line transforms raw materials into one of the strongest construction materials on Earth. Every stage requires accuracy, timing, and advanced engineering. Visual description: camera enters the factory through huge industrial doors, show massive conveyor systems, rotating machinery, control rooms, and workers monitoring operations. The first major step begins with crushing. Large limestone rocks extracted from the quarry are too big for processing, so powerful crushers reduce them into smaller pieces. Machine explanation: machine name, limestone crusher. Function: breaks large rocks into smaller pieces suitable for grinding. How it works: large rocks enter the crusher chamber, where powerful mechanical pressure breaks them into controlled sizes. After crushing, the materials must become extremely fine. Grinding machines transform rock fragments into a powder that can later be chemically processed. Machine explanation: machine name, raw mill. Function: Grinds limestone and other materials into fine powder. How it works. Large rotating cylinders and grinding media create pressure that reduces materials into microscopic particles. Visual description. Show giant raw mills, rotating drums, powder movement, and engineers monitoring the system. Creating strong cement requires the perfect balance of ingredients. Automated systems carefully measure and combine different minerals before the heating process begins. Machine explanation. Machine name. Blending system. Function. Combines raw materials in accurate proportions. How it works. Computer-controlled systems adjust the mixture according to chemical requirements. Visual description. Show computerized control rooms, material silos, and automated mixing systems. Deep inside every cement factory is the most important machine in the entire process, the rotary kiln. Here, extreme heat transforms prepared raw materials into a new substance called clinker, the foundation of cement. Machine explanation. Machine name, rotary kiln. Function, converts the prepared raw material mixture into clinker. How it works. The long rotating cylinder slowly moves material through extreme heat. Chemical reactions remove carbon dioxide and create hard clinker pieces that become the main ingredient of cement. Visual description. A massive rotary kiln glowing with intense heat. Workers monitor temperature systems while flames burn inside the kiln. Show the scale of the equipment compared with humans. After passing through the intense heat of the kiln, the material emerges as clinker, small dark gray pieces that hold the chemical structure needed to create strong cement. Machine explanation. Machine name, clinker cooler. Function, rapidly cools hot clinker after leaving the kiln. How it works. Powerful air systems reduce clinker temperature while recovering heat energy for improved factory efficiency. Visual description. Freshly produced clinker falling from the kiln into cooling equipment. Hot materials glowing before becoming solid gray pieces. Clinker alone is not cement. It must go through another critical stage where it is ground into a fine powder and combined with gypsum to control setting time. Machine explanation. Machine name, cement mill. Function, grinds clinker into finished cement powder. How it works. Large rotating mills crush clinker particles into extremely fine cement while additives are mixed in precise quantities. Before cement reaches construction sites, every batch must pass strict quality tests. Engineers analyze chemical composition, strength, and performance to ensure reliability. Machine explanation. Machine name, cement testing laboratory equipment. Function, measures cement quality and strength. How it works. Samples are tested through chemical analysis, compression tests, and laboratory evaluations. Once approved, the finished cement moves towards storage and packaging. Automated systems prepare millions of kilograms of cement for delivery every day. Machine explanation. Machine name, storage silos. Function, store finished cement safely before packaging. How it works. Large sealed containers protect cement from moisture while maintaining controlled conditions. From mountains of raw stone to a refined construction material, the journey of cement is a masterpiece of engineering. But this is only the beginning. The next challenge is moving this powerful product across the world. Visual description. Show complete cement bags, factory loading areas, trucks leaving the plant, and a final aerial shot of the factory. Once the cement passes every quality inspection, automated packaging systems prepare it for delivery. Every bag is filled with remarkable precision, ensuring consistent weight and reliable quality for customers around the world. Machine explanation. Machine name, automatic cement packing machine. Function, fills cement into bags with accurate weight and seals them for transport. How it works. Bulk cement flows from storage silos into high-speed filling nozzles. Sensors monitor weight, after which the bags are sealed and released onto conveyor belts. Before shipment, finished cement is stored under carefully controlled conditions. Protection from moisture is essential because even a small amount of water can begin the hardening process. Machine explanation. Machine name, cement storage silos. Function, safely stores finished cement. How it works. Uses enclosed steel or concrete silos equipped with aeration systems to maintain smooth material flow while preventing moisture contamination. Every shipment marks the beginning of another construction project. Bulk cement and packaged bags are loaded into trucks, rail cars, and specialized tankers designed to protect the material during transport. Machine explanation. Machine name: bulk loading system. Function: transfers cement efficiently into transport vehicles. How it works: automated loading spouts deliver measured quantities while dust collection systems reduce airborne particles. From remote factories to crowded cities, millions of tons of cement travel through vast transportation networks, supplying homes, hospitals, schools, and infrastructure projects. Visual description: convoys of trucks on highways, rail freight crossing bridges, aerial views of transportation routes. Not every destination can be reached by road. Large quantities of cement and clinker are shipped across oceans, connecting producers with construction projects on other continents. Machine explanation. Machine name: ship loader. Function: loads bulk cement and clinker onto cargo vessels. How it works: conveyor systems transfer material directly into ship cargo holds while minimizing dust emissions. Visual description: cargo ships at port terminals, giant loading arms, cranes, and conveyor systems. Cement supports the growth of both developing and developed economies. Expanding cities, transportation systems, energy facilities, and public infrastructure all rely on a dependable supply. Visual description: construction of bridges, apartment towers, highways, dams, and renewable energy foundations. Today, cement production spans nearly every region of the world. Different countries specialize in raw materials, manufacturing, engineering, and large-scale construction, forming a global industrial network. Visual description: animated world map, factories on multiple continents, ports, freight routes, and major construction projects. Every year, billions of tons of cement are produced worldwide, making it one of the most widely used manufactured materials. From towering skyscrapers to neighborhood sidewalks, its presence is almost everywhere. Visual description: fast montage of famous skylines, highways, tunnels, residential buildings, airports, and industrial megaprojects. Only days after leaving the factory, cement begins its final transformation. Mixed with water, sand, and aggregates, it becomes concrete, the material that gives strength to buildings and infrastructure. Visual description: concrete mixing, pouring foundations, finishing surfaces, curing concrete, and completed structures. The journey from raw stone to global construction is complete. Yet the cement industry now faces a new challenge: building a stronger future while protecting the planet that provides its raw materials. Visual description: sunset over a modern cement plant, dissolving into green landscapes, wind turbines, and innovative industrial technology. The world depends on cement, but can this essential industry reinvent itself for a cleaner, more sustainable future? The final chapter explores the innovations that may redefine construction for generations to come.